As we continue with the application for trigonometrical ratios, we have a number to do here to demonstrate some of this application. The question says that we are given cos theta, which is 3 over 5, and theta is an acute angle. We all know that an acute angle is an angle that lies between 0 to 90 degrees. So we are asked to use this information to find the values of sine theta, sine squared theta plus cos theta, and so forth. So let's try and do this number. We have cos theta giving us 3 over 5. So we know that the cosine of theta is equal to 3 over 5. And we know that this is an acute angle. So if this is an acute angle, it means that the right angle triangle we are talking about will be like this. This is the right angle. That is the value of theta. From our SOHCAHTOA, since we are dealing with cos, we know that cos is equal to adjacent over hypotenuse. So if you look at this angle theta, the cosine of this angle theta is going to be equal to the adjacent, which is 3, over hypotenuse, which hypotenuse is 5. So since we know that the adjacent is 3 and the hypotenuse is 5, it means we can use Pythagoras theorem to get the length of the remaining side. And the length of the remaining side using Pythagoras theorem, let's call this x. To get x, we shall say x squared plus 3 squared is equal to 5 squared. Upon getting the value of x as 4, so we know that our triangle is now complete. This is 4. So after getting our value of x here as 4, then we can complete the rest of these. We know that for cos theta already, cosine of theta is 3 over 5. So what about sine? We know that the sine of that very angle theta is going to be equal to opposite. So opposite that is 4. So it is going to be 4 over hypotenuse. Hypotenuse is 5. So the hypotenuse is 5. Then we go to the tangent, or the tan. The tan of theta is going to be equal to opposite. Tan of theta is opposite, which is 4, over adjacent. Adjacent to this angle is 3. So we have the cos theta of that, the cos, the sine and tan of that angle. So after determining our cosine and tan, then we are now in position to answer the rest of the question. Now the first part of the question is requiring us to find the sine of theta. Now of course, now here part A, sine of theta is equal to, we've already gotten sine of theta, it is 4 over 5. So we go ahead, part B, sine squared theta plus cos theta. It's just a matter of substituting what we've gotten. So part B, sine squared theta plus cosine theta is the same as saying sine squared theta is the same as saying sine theta squared. And sine theta squared is 4 over 5. So it's the same as saying 4 over 5 squared plus our cos theta. Our cos theta here is 3 over 5. So it's going to be plus 3 over 5. Going to give us 16 over 25 plus 3 over 5. And our answer will be, so we go ahead to the next. It's requiring us to find sine squared theta plus cos squared theta. Part C, sine squared theta plus cosine squared theta. That's going to be equal to, now sine squared theta, we already got our sine. The sine of theta is 4 over 5. So it's going to be 4 over 5 squared plus our cos theta is 3 over 5. So 3 over 5, and this is also squared. So this is going to become 16 over 25 plus 9 over 25. And our answer here definitely is going to become 1. That is part C. So part D, same story, we're just simply going to substitute in those. So our part D is 2 sine theta cos theta is going to be equal to 2 sine theta. Our sine theta already gotten as 4 over 5 times 4 over 5 times cos theta. Our cos theta is 3 over 5. Then next we have tan theta plus 1. That is our part E. Tangent of theta is going to be plus 1 is equal to our tan theta. We got tan theta as 4 over 3. So this is going to be equal to 4 over 3 plus 1. And that's simply going to give us 7 over 3. And that's going to be our answer.